All right, hey everyone. I'm Leland. I do Android development on Uber's mobile platform team, and I'm also the author of Motif, which is our dependency injection library that we're open sourcing. I thought about starting out this talk with kind of an overview of dependency injection, what it is, and why it's important, why it's useful, but I think there's a lot of resources out there already. There's a lot of presentations that have covered this topic, so I'm going to spare you all the dependency injection 101 and jump right into some specifics on Motif itself. And specifically, let's dive into a question that I think is kind of the elephant in the room, which is, why do we need a new dependency injection system? And first, we'll talk about Dagger versus Motif. And the first thing I'll say, actually, is that Motif is actually an abstraction on top of Dagger. It offers a completely separate, slimmed down, simpler API, but under the hood, it's actually generating Dagger. But with that said, let's take a look at Dagger and Motif API and some of the high-level concepts to keep in mind as we go through this presentation and as you consider whether or not Motif is a right choice for you in your applications. So let's take a look at Dagger first. Dagger, as we know, is the industry standard. It's been around for a while. It's been proven in production in many different types of applications. It's a robust framework that we all trust, right? And part of the reason why Dagger's gained this level of popularity is because of its flexibility. And that is to say that Dagger can satisfy a lot of different types of applications, a lot of different structures of dependency injection graphs. But with this flexibility, Dagger's API has kind of grown and grown. And as new use cases crop up, the API has kind of added more and more features. And again, as a generic framework, this is kind of the right decision for Dagger because Dagger needs to play that role of a kind of base DI framework that can satisfy all the different use cases, whether it be a small individual application developer or enterprise company building out an app. Dagger can satisfy all those use cases. But ultimately, that means that Dagger has a lot of concepts to understand to satisfy all these different use cases. So that will result in a higher or a steeper learning curve for developers and also may take a toll on developer productivity. All right, so those are some of the points to keep in mind. Let's take a look at Motif now. Motif is pre-release. We've open sourced it a few months ago, I think now. We are using it in production at Uber. So we've converted about 100 of our Dagger components to use Motif, and we haven't seen any problems in production. So we're pretty confident in the robustness and the correctness of Motif, but the API might change slightly because it is still a pre-release library. A second point on Motif is that as opposed to Dagger's, or in contrast to Dagger's flexibility, Motif is an opinionated framework. So we have targeted a kind of narrow set of use cases as opposed to trying to solve all the patterns under the sun. We've targeted a few narrow use cases, and because of that, we've been able to design an API that's highly optimized for those use cases. So what that results in is many fewer concepts to understand by the developer because we're not trying to solve all the use cases that Dagger does, for instance, and just a slimmer and more intuitive API. Okay, so with that out of the way, I think the next thing what we'll do is go into some of the background in why we actually came to the decision of, we need to build a new dependency injection framework because that's a very heavy-handed solution. So there must be a good reason why we did that. So we'll take a look at that now. And we'll start by just talking a little bit about mobile architectures in general. And here I mean MVC, MVP, MVVM, Viper, Ribs. But no matter what you're using out of these frameworks, they're all trying to solve a similar problem, and that is managing code complexity. We know that mobile applications don't have to deal with the same sort of scaling issues that, say, a backend service would. Backend services might need to deal with things like requests per second. A mobile application, on the other hand, deals with different types of scaling issues, right? We need to deal with things like scaling up number of developers working in the same code base and dealing with code complexity scale and lines of code. So what all these mobile architectures try to solve is dealing with those problems, right? And what they do is they solve it in kind of similar ways by breaking down that complexity into composable business units. And we'll just from here on out call these scopes. And depending on the framework you're using or the patterns you're using, you might be calling this something differently, but we'll just use the generic scopes as a term that we'll use in this presentation. So here's an example of how you might break down some application into scopes. At the top, you might have a root scope, and if you're using MVC, maybe this is a root controller with associated views and models. And when the user logs in, maybe you attach a logged in scope. And with MVC, again, this might be a logged in controller with associated views and models. And rib world, that might be a logged in router, interactor, and a builder. But you keep on doing this and breaking this down, and what this allows you to do is it allows you to isolate features. So if you have many developers working in the same code base, it allows developers to iterate and move quickly within their own feature without fear of breaking other parts of the application. So that's a benefit of scoping your application in this way. At Uber, we've taken this kind of to the extreme, and we have over 1,000 scopes in our code base. And again, this is because we have a large, complicated application with the many lines of code and a lot of developers working on our code base. We have around 200 developers, Android developers working on our app, right? So what all does this have to do with dependency injection? If we're talking about Dagger, we could structure our DI graph in many different ways here. We could say there's only one component for the entire application. So let's take that scenario. If we have one component for the whole application, there are some problems here. The first problem I see is that no matter what scope you're working in, all these dependencies have a global visibility. So when we're asking ourselves what dependencies are available in my scope, you actually have to consider every single dependency that's declared in your application. Second problem with this, aside from visibility, is lifecycle. And what I mean by that is that if you have only a single component for your entire application, not all the dependencies that you would like to be on the dependency graph are available at app startup when you need to create that component. So that doesn't really work that well either, and you end up with a lot of stateful, nullable dependencies, right? Okay, so let's try to solve those problems. Maybe we can have several components for our application and kind of mitigate that issue a little bit. The solution that we've found to be the most effective is actually having a component and a module per each of these scopes. And this gives us the highest level, the most control over, again, dependency visibility and dependency lifecycle. One of the conversations that comes up in design discussions around how do we structure our feature and how do we break our feature down is where do we put our dependency? At what scope should we place our dependency? And oftentimes that dependency ends up being in the same scope that it's consumed at. And this is if that scope is the only scope consuming that dependency. But let's say we have many scopes consuming the same dependency. Then our rule is that that dependency should live at the lowest common ancestor amongst all the scopes that are consuming that dependency. But in this way, we can have our dependency live in a place that limits the visibility and lifecycle of that dependency. And the way we can do that is with this pattern, having a component and a module per each of these scopes. And you might be thinking now that, wow, that sounds pretty painful to have a component and a module per every one of these over 1,000 scopes that you have in your code base, and that's true. And that's one of the reasons why we built Motif. But let's take a look at the actual code that is defined by each of these scopes for dependency injection. And this is a bare minimum for any of our scopes. This is just the basics that we use here. And you can see right away that it's a little bit difficult to scan over this and understand exactly what's going on. And of course, advanced Dagger users would be able to go line by line and understand each of these concepts. But just glancing over this, it doesn't give you a good sense of the structure of what it's trying to represent. So to help us out, we'll just highlight the important bits. So these are the bits that developers would often care about when they're reading this code or writing this code. These are the pieces that don't change between scopes. You can see that the signal-to-noise ratio here is pretty low. There's a lot of surrounding boilerplate, and I'm claiming that we don't necessarily care about that when reading this code, given our patterns, and we'll talk a little bit more about that later. But first, let's just go through each of these and talk about what they represent. So of course, at the top level, this is just the component interface definition. Tells us what scope we're in, contains all of the dependency injection logic, right? And the first method on that component is a component provision method. So this says, I need to be able to create a controller, and when I call this, all the code-generated code, please resolve all the dependencies and instantiate a root controller for me and return it to me. And this is required because this is required so that some other code can have an instance of the component and then request to pull dependencies off of that component, right? So that's important to be able to do. This next method is also very important. This is what actually gives us that scope graph structure. So that diagram we were looking at earlier, this is what defines those edges. It defines the parent-child relationship. And this is a subcomponent factory method that's returning a subcomponent builder, right? And it's saying that logged in is a child of root. Moving into the component builder, this method's a little bit more nuanced, but it's essentially what it's saying that we are able to inject a view group into the child dependency graph. Another canonical example here would be an auth token. So let's say you're in the root scope and you retrieve the auth token over the network, and you want that auth token to be available in the child scope, but it's obviously you can't provide that statically from the parent since it was retrieved over the network. This is a way to inject that into the graph and have it be available on the dependency injection graph from logged in down to any of the descendants. Okay, and finally, this is a provides method in the module, and this is probably the most familiar to us. This is just telling Dagger how to create a root view, right? You just call this method and pass in a view group as a dependency of root view. Now, each of those concepts and all those concepts are not very complicated, and yet there's a lot of code involved to actually define and express what we want to express here in Dagger's world. And this is the problem that we were seeing and got us starting thinking about how we can actually abstract this repeated complexity and make our lives a little bit easier. And in addition to the boilerplate in terms of lines of code, there's also a lot of concepts here that we have to understand. On the left-hand side here, these are all of the concepts that we use just in that example that we just looked at. Right? I'm not going to go through all of them because there's a lot. On the right-hand side, we have some decisions that we have to make when defining our patterns at a platform level. So should we be using components or component dependencies, subcomponents or component dependencies? Should we be using component builders explicitly defined by our developers, or should we use Dagger, just allow Dagger to generate that interface for us? So these types of decisions we have to make when designing our patterns, but the decisions we make don't change from scope to scope. We define them once, and then we just have developers implement that pattern for the scope that they're working in, right? But of course, Dagger doesn't know what our patterns are and doesn't know about the fact that we have a lot of scopes and have them deeply nested within each other. So we have to tell Dagger every time we define a scope exactly what we want. So this is one of the reasons why, or one of the things that adds to the repeated complexity that we're trying to avoid. So how do we solve the fact that we have all this repeated dependency injection configuration? Well, normally we've all kind of internalized strategies for factoring out duplicated logic. So maybe we'll immediately identify a method that can be factored out of some duplicated code that we see, or some helper method that might be useful in a certain scenario. But what we're talking about here is a little bit different. You can't factor out this sort of repeated patterns in the same way that you would for just raw Java logic, right? So we needed another strategy, and that's exactly what Motif is. Motif is an annotation processor that generates Dagger code under the hood. And in fact, it's generating code that's very similar to that code that we would have written manually. And we'll take a look at Motif's API in a little bit. But first, I'll just point out a couple other things about Motif. The second point is that it offers full interoperability with Dagger. So we'll take a look at exactly what we mean by that in a little bit. And also, Motif infers scope dependencies. So just like subcomponents would in the Dagger world, if you define a scope that needs dependencies from the parent, Motif will actually be able to infer that without you having to explicitly define it. So very much like subcomponents in Dagger world. And finally, the driving principle behind Motif's API design is just API simplicity. So you'll see that when we get into some of the code samples for Motif, but this is something that we valued highly when we were designing Motif. Okay, so what does our DI setup look like now that we're using Motif? Instead of that single component and single module per scope, we now have a single Motif scope per each of these scopes. And again, it's an abstraction on top of Dagger, so under the hood, we're still generating the component and the module, but we're dealing with a much simpler API and a higher abstraction. So here's a code that we use for Motif, and this is equivalent to the Dagger code that we saw earlier, and you can tell that it's obviously much cleaner and much shorter in terms of lines of code. And more importantly, there's many fewer concepts that you need to learn to understand what's going on here. So we'll do the same exercise where we highlight the important bits, and the signal to noise ratio is obviously higher here, right? Like when the code that you write out explicitly is almost all of the code that's actually committed to source control, and that's really important to us. So we'll go through again each of these and kind of define what it's doing. At the top level, we have the root scope, and this is analogous to the Dagger component. This is just the top level interface that defines the container for all the dependency injection logic. And Motif does a very similar thing to what Dagger does in that it will generate the implementation, co-generate the implementation of this root scope interface, right? And the first method here is exactly the same as the Dagger component provision method. We call it a Motif access method, but it does the same thing and it has the same syntax. It allows you to pull off of the root scope a root controller, and internally the code-generated implementation will know how to resolve all of the root controller's dependencies and instantiate the root controller. If you think back to the Dagger example, this is the subcomponent factory method that we were talking about, and in the Dagger world we returned a subcomponent builder. Here we're just returning another scope. So we've kind of removed a layer of abstraction there. And one difference that we'll see is that this actually takes in parameters. And this is so that we don't need to use the binds instance annotation that we had in the Dagger example. In order to pass in those dynamic dependencies that we were talking about, that auth token, we just need to define a parameter to this child method, and we can just pass it in when calling this method. Okay, moving into the objects class here. This is analogous to the Dagger module. And this is where we define, or we tell Motif how to instantiate different dependency types. So this first method tells us how to instantiate the root controller. And you'll remember that there actually wasn't an analogous method in the module for a Dagger version. And that's because in Dagger, this type was constructor injected. And Dagger was able to infer that by looking at the constructor of this object and seeing that it was annotated with @inject. So why didn't we do that and leverage the same API for Motif? Well, we think it's really powerful to be able to look at the objects class and know that every method that's defined there represents all of the dependencies that this scope can provide. And we think this is really useful because in the Dagger world, not all the dependencies that are provided by a scope are actually listed in one place. It could be scattered across your code base with constructor injected objects. And finally, this is the analogous of the view method that we were looking at in the Dagger module. And this is just saying in order to instantiate the root view, call this view method and pass in the view group as a dependency. So same thing, just minus some of the annotations that we had to declare in Dagger. All right, so that's it. That's it in terms of the Motif API. So let's look at the concepts that we went over. This is a list of the concepts that we used in that previous example. And although that example is pretty basic, this is almost all of Motif's APIs. So again, driving home that idea of API simplicity. Just the basic example, it covers most of the API. There's maybe a few other concepts to learn, but you can tell by just looking at these concepts that onboarding and more importantly, long-term understandability and readability will be greatly increased if you commit to the sort of patterns that Motif can handle, right? Okay, so I'm going to switch gears a little bit here and talk about something I mentioned a little earlier that some of you might be interested in, which is Dagger Interoperability. So we stripped out a lot of the other methods in this root scope, and we've just left the child scope, the logged in method here. And again, just to recap, this defines logged in scope as a child or root scope here. So when we talk about Dagger interoperability, we're going to keep in mind two questions. And the first question is, what if logged in scope is a Dagger component? So can we have a Dagger component be a child of a Motif scope? So this scenario would be something like if you had a, by and large, motif-based application, can you attach a Dagger component as a child to that, some feature that's already using Motif? And the second, the converse, is what if root scope is a Dagger component? So can we have a Dagger component that's a parent of a Motif scope? So this would be probably the more common use case, which is if you have an application that's already using Dagger, can you attach a Motif scope just to try it out or begin migrating? So both of these are possible, so we'll take a look at each scenario. The first scenario being Dagger as a child of Motif scope. And the first thing you do is define your component as you normally would, and define your dependencies as you normally would, except instead of passing in a component class here, you pass in a Motif class, a Motif scope rather. And the reason why this works is because Motif scopes and Dagger components share the same syntax for these provision methods, and that's what Dagger looks for on this dependencies definition. So when you go to instantiate the component, all you need to do is pass in an instance of the Motif scope now, and that's it. So it's a pretty seamless integration, and in fact, Dagger treats the Motif scope exactly in the same way that it would treat a component dependency. So the second scenario is Dagger as a parent of Motif scope, and this is almost just as simple. We said that Motif generates an implementation of the Motif of the scope interface that you define, and along with that code-generated implementation, it generates this dependencies interface, and this lists out all of the dependencies that are required from the scope's parent. So now what we can do is have the component directly satisfy all those dependencies by extending this dependencies interface. And when we new up the scope, we can just pass in an instance of the component as the dependencies, and now we've set up Dagger as a parent of Motif scope. So using these two strategies, you can opt in or opt out of using Motif however you want, and this is really useful, for instance, just trying out Motif or doing an incremental migration if you wanted to do that. Okay, so that's kind of the end of the API portion of this and the comparison with Dagger, and I wanted to get into some architecture pieces because I think it enables some really cool things. The first thing we'll look at in Motif's architecture is the IR. So this is the intermediate representation that abstracts away the representation of the Java AST. And we've implemented this both in the annotation processing world and also in the IntelliJ plugin world. And we'll see what that looks like in a little bit. But what's great about this is that the subsequent logic here and the subsequent flow doesn't know whether or not we're in the compiler or the IntelliJ world. So we'll take a look at this IR for a second. These methods these interfaces on the left are satisfied in two different worlds again, which with the javax.lang.model namespace, and this is the annotation processing models. So the annotation processing representation of the Java AST. And the com.intellij.psi models. And this is IntelliJ's version of the Java AST, and this is the way IntelliJ represents Java source code, right? And diving a little bit more into that, here are the actual definitions of the compiler and the IntelliJ versions of these models. So once we've implemented the IR, the next step we need to do is take that representation of Java source code and transform it into Motif-aware models. And these models would be things like access method, child method, factory method, objects class, scope. And along the way, we can catch things like maybe we've defined a method on a scope might be a valid Java method, but it doesn't make sense in Motif world. Well, we would catch that here and we would throw a parsing error, let's say. So once we've got these Motif models, kind of these Motif primitives, we process it into a validated graph. Because before this process graph step, we didn't know what the dependency graph looks like. So that's what we construct here. We construct an in-memory representation of the dependency and the scope graph. And this is also where we catch things like missing dependencies. So if we've defined a scope that requires dependencies that isn't satisfied by any of its parents or ancestors, then we'll throw a missing dependencies error in this step here. We'll also catch things like dependency cycles or scope cycles, which aren't allowed. But once we have that validated graph, this in-memory representation of the dependency graph, we'll hand it off now to either the compiler to code generate our implementation of the scope interface that we define, or we'll update the UI in some way. And we'll take a look at that use case in a little bit. And that's this piece here. So again, most of Motif's logic is actually unaware of whether it's operating in the annotation processing world or in an IntelliJ plugin. And that's really powerful, and we'll see why here. This is still under development, but this is kind of what we envision for the future of IDE integration for Motif. Once we have a full graph understanding inside of an IntelliJ plugin, we can do really cool things like real-time graph validation. So we all have run into that dreaded missing dependencies or missing bindings error in Dagger world. And we have to fix that in our source code and recompile to figure out whether or not that passes. So with full integration with the IDE, we can do this much quicker and have a much faster iteration cycle here and feedback loop. And it behaves much more like a linter, right? The feedback is instantaneous. And that's because the IntelliJ plugin has full understanding of the graph. We can also do things like visualizing the scope hierarchy inside of the IDE. And again, we can trust that just as much as we trust the compiler because they share the same understanding of the graph and the same core logic. Another thing we can do is navigate to who provides a given dependency. And that's really powerful when you're trying to track down which one of your ancestors actually gave me this dependency, right? So this is something we're really excited about. It's not fully developed yet, but it's definitely in the works, and it's enabled and made possible by the fact that we built out that IR up front to abstract away the Java AST. So that's all I have for you guys today, and if you're interested to learn more, check out this GitHub repo and let us know what you think. All right, thank you.